Okay, hi guys, good day. So let's try to continue with our topic on lesson 4 and 5, triangles, quadrilaterals, and this time let's try to include circles. Okay, so for this problem we have, in the diagram below, two smaller identical semicircles are drawn inside a larger semicircle having a diameter of 14. What is the area of the shaded region? Now, we are only given for this figure is that the diameter is equal to 14. Okay. Now, if the diameter of the larger circle, of the larger semicircle, is equal to 14, now what is its area? How do we solve for the area of a circle? So as mentioned before, the area of a circle is equal to pi r squared. Now, since it's a semicircle, from the word semi, so that means it's only half of a circle. So therefore, this formula that we have here, we have to divide it by 2, since it's just a half. Okay, so therefore, the area of the semicircle is just going to be area of semicircle is equal to pi r squared all over 2, or 1/2 times pi r squared. Now, our given here is the diameter, and the diameter is equal to 14. To solve for the radius, we just have to divide both sides by 2, and d over 2 is just the radius, and therefore the radius is just 7. Now we can solve for the area of the semicircle. The area of the semicircle is just going to be pi times 7 squared all over 2. So that's pi times 7 squared, which is 49. So that's 49 pi divided by 2. And what's 49 pi divided by 2? Again, in our subject, guys, please maximize using your calculator, whether it be an online calculator or an offline calculator or your cell phones or your smartphones calculator. Please maximize the use of the calculator in my class. So 49 pi divided by 2, so that's equal to 76.96, or if we round that off, so that's 76.97. So therefore the area of our semicircle is equal to 76.97 squared units. Now, we still have a problem though. We have these two smaller semicircles, these white parts, that we have to find the area of. Now, how do we know the radius or the diameter of these semicircles? Since both of them are originating from the center of this bigger semicircle. So therefore, what we can do is this 14, we can divide that by 2. We can say that the diameter of the first semicircle of the smaller semicircle, its diameter is equal to 7, and the diameter of this other circle is equal to 7. Now, using the same formula that we have for the area of a semicircle, so that's going to give us pi r squared divided by 2. Since we know that the diameter is equal to 7, we can divide that by 2. So therefore the radius is just equal to 3.5. So therefore the area of the smaller semicircle, those two, so that's going to give us pi times 3.5 squared divided by 2. Using again your calculator, so that's pi times 3.5 squared divided by 2, so that should give us 49 over 8 pi, or if we're going to use the decimal, so that's 19.24. So that's 19.24. So that's just one semicircle. So since there are two of them, just multiply that by 2 times 2, so that should give us 49 over 4 pi, or approximately equal to 38.48. There you go. So therefore, the area of the two semicircles is equal to 38.48, and the area of the bigger semicircle is equal to 76.97. Now, since we want to find the area of the shaded region, what we can do is to get the area of the shaded region, we can get the area of the big semicircle minus the area of the small semicircle for this one. So this is going to give us 76.97 minus 38.48. Now, what's 76.97 minus 38.48. So that should give us 38.49, or approximately that's around, if you round that off, so that's around 38.5. Here you go. So therefore the area of the shaded region for this problem is equal to 38.5 squared units. Okay, so that's letter B. Okay, so that's 38.5 squared units, and that's the answer for this problem.